Hey there, grade 6. New video for you guys today on reflections. It is the second of our series of transformations that we are looking at. Last video we looked at translations, and today's going to be on reflections. And so the goal for today is that you're going to reflect points and shapes and describe reflections. And the second learning target is that you are going to verify that reflections take polygons to congruent polygons, which is just a fancy pants way of saying, like, when you do a reflection of an object, the resulting reflection or the mirror image will be a congruent shape. Like these two are congruent shapes. They are identical in shape and size. But before that, a couple of skills. You need to be able to draw and identify perpendicular lines. Perpendicular lines, as we remember, are lines that intersect at a 90-degree angle. You need to be able to measure sides and angles of polygons, which is a fancy way to say you can use a ruler and a protractor. You need to be able to identify congruent shapes, which basically means you can look at two shapes and say, or do some sort of measurement of side lengths and angles and say, yep, these are identical in shape and size. And you need to know the definition of congruent polygons in terms of saying this angle, like angle D, is equal to angle D prime, that kind of stuff. So here we have our two shapes, and the question that they want to focus on is, what should I do to place A on top of B? Last video we would have looked at being able to slide A on top of B. This time that's not going to work, and what we're going to need to do is we would need to imagine that there is like this mirror line that I can draw, and then I could flip A on top of B. And so if I were to take this shape, one of the things I could say is I want to flip this, and I'm going to flip it left to right. So if I flip the shape, then that would be able to fit on top of it. Now I have to imagine I flip, I'm pointing on my screen, I flip over top of that mirror line, but that's what you basically be doing, right? So that means it's a kind of reflection. It's another kind of transformation. These two shapes are mirror images of each other. And so what we moved on is that there are different ways to reflect a shape. So I'll use that same tool, and I can draw these lines between these shapes that would indicate how you would reflect them. And so the top one here is a vertical reflection, this one's a horizontal reflection, and this one would be like a diagonal type reflection. But basically the shape gets reflected over top of itself, not over top, beside itself to create a reflection. Okay, so this is where we start. We start by reflecting just points, right? And this would match up with like the first question in your workbook on page 51, where you're going to reflect just a point. Okay, so there are some steps to go through. So first step is that we would draw a line perpendicular to M. This is our mirror line, and so I'm going to do that. So here is our perpendicular line. And then the second step is that you could measure the distance from A to M. So what I could do is insert here a measurement tool like a ruler, and I could actually, I gotta select that, and I could measure this distance to see that the distance from A to the mirror line is about 2.5 centimeters. And so that's my next step. I would mark A prime on the other side of M, right? So I'd get my measuring tool out and line it up and say then I need a point at 2.5 centimeters, which would be right about there. And then I could mark that as A prime, which we learned in our last video, just is a way to write a transformation, right? In this case, it's reflection. So we say that point A prime is the image of point A under reflection. That's just a fancy pants way of saying, like, I've reflected point A across that mirror line. So if you want, you could pause it for a second and go through these steps, draw a horizontal mirror line, mark point A, just practice it on your own, the same stuff that I just did, and then you can pick it up as we go. Something else you could try is on a grid, you could draw a scalene triangle. You could label the vertices and measure its sides and angles, then draw a horizontal or a vertical line of your choice. This is going to be your mirror line. You could reflect the shape across the mirror line and then you could measure the sides. This actually matches up with number 2 in your books on page 51, and so that's what you're going to be doing. So rather than me doing it on the screen here, practice it in your book. And then so some things that you might notice is the vertices that they might change. You will notice that hopefully when you do number 2 in your workbooks. So the next question that we're going to focus on is, what do you know about the sides and angles of congruent polygons? Well, we should hopefully know that side lengths are the same and angles are the same if we have 2 congruent polygons. And then the question is, do reflections take polygons to congruent polygons? The answer is yes, they do. They take polygons to congruent polygons. And so this statement is true. If polygon A is a mirror image of polygon B, then A and B are congruent. This one is true. But does it work the other way around? If polygons A and B are congruent, then polygon A has to be the mirror image of polygon B. So can we find an example that shows that this statement is false? And here's the example. These 2 triangles, these 2 right triangles are congruent. They are not mirror images. There's no place that I could draw, you know, any kind of mirror line that would show that it's a reflection. So it's not true. This is a result of a translation, not a reflection. So then there's another activity here. It says, on grid paper, draw a horizontal and a vertical line as mirror lines. In one part, draw a right trapezoid and then label it D, E, F, G. Then we'd have to reflect our trapezoid horizontally. So here is some grid paper. I'm going to draw 2 mirror lines. So I'll draw one vertically, put it right here. I'll draw another horizontally and put it here. Then I'm going to insert that one. Nope, not that one. I'm going to insert a shape that is a trapezoid so that it looks, actually, yeah, close enough. So that it looks like this. And then what I'm going to do is I'm supposed to label it D, E, F, G. So say that's D. We'll say that's E. And we typically go around the, right, here's F. And then here's G. So this is our trapezoid. Sometimes I don't know why they don't draw it out. Anyway, so here is our shape. And then what I'm going to do is I'm going to flip this thing, and then I'll move it. We're going to imagine that I'm reflecting it. So I'm gonna do a left to right flip. I'm going to copy and paste it, and imagine that I've flipped it over here. Now it's got to be the same number of units away, so it's got to go here. Now here's what's going to happen to the labels. This is going to be E prime. This is going to be D prime. This one here is going to be F prime, and then this here is going to be G prime. And so what we need to sort of figure out is this concept that when you do the reflection, the order of the points is going to shift. Okay. So likewise, if I copy and paste again, I'm going to flip this thing up and down. And then I'm going to imagine that this is going to be reflected. Let's see, E's got to go there. So that's, if I were to do a reflection like this, this point here is going to become F, let's say double prime. This point here is going to become E double prime. This is going to be our D double prime, oh, wrong symbol, D double prime, and this again is going to be G double prime. And so again, notice this is D, E, F, G, D, G, F, E. So the order of the points is going to change depending on if it's, you know, a horizontal rotation reflection or a vertical reflection. Okay. And so, yeah. All right, moving on. It says that these two polygons are reflections of each other. It says to join the corresponding vertices with line segments and then use midpoints to find the mirror line. So let's just do these ones. So here is a line segment that would join those 2 points. Here's a line segment that would join these 2 points and these two, and then I'll do these ones. I know that I missed a couple in here, but it'll be okay. So then here's the midpoint of all of these lines. And then basically what I can do is I could join these midpoints up like this, and that would be this line here that I've just drawn. If I can change the color for a sec. So that's my mirror line. Now notice the interesting thing, like this green shape was sort of like partway across the mirror line, and so the reflection is also partway across the mirror line, but just on the other side. So if this is my image, this is my prime image. Let's say it like that. Okay. But I can use line segment midpoints to find a mirror line, right? So if I just have 2 independent shapes that look like they've been reflected, I can join them up with line segments, find the midpoints of all those lines, and that's going to actually match up with numbers 3 and 4 in the workbook on page 52. So then that would be what you're doing, is finding some mirror lines, right? Now, here's a bit of a tricky one. It says, are these mirror images of each other? And so I would contend, if I highlight this and I click on the flip left and right, when I do that, we notice that it actually looks like it's a mirror image. It's just been also moved. And so I'm going to say that yes, this is a mirror image of each other, but this is kind of what's happened. It's undergone a combination. It's undergone a reflection and a bit of a translation. And so if we were to take this, if I were to unlock this, and then I were to copy and paste it, and then flip it, so let's say I flip up and down, right? I got to make sure that it's in the same spot, the best I can. There we go. So this becomes like T prime, right? So I can't change the, but then what I could do is I could say, okay, so this has been reflected across the mirror line, but I'm also going to move it over, let's say I move it over 1, 2, 3 units. Okay, so it has actually undergone a reflection across the horizontal line and then a translation. So you can do that, and that will match up with some of the questions on page 53, looking at like number 6 through number 6 and 7 to the end. Okay, and so that's how we can do that. So sometimes, with the last couple of comments, sometimes this is no single transformation to take one shape to the other, and 2 transformations are needed. I just showed you a reflection and then a translation. There's more than one way to do it. You could do the translation first and then the reflection, or the reflection first and then the translation. But if you haven't been keeping up with the suggestions for questions, at this point it's 51, 52, and 53 in the workbook. You guys, thanks for listening. I hope that that's been helpful in your work, and have a great day, and I'll see you next time.